All right, as we go on to example 9, we're continuing with conditional probability. And in this case, we have 290 students were asked about their satisfaction with their interaction with the financial aid office on campus. Their responses are given in the following table. So, we're going to need some of this information, and I don't know that you can write it all down, but let's take a look at it. So we have the classes, freshmen through graduate students. In this column, those that were satisfied, those that were dissatisfied, and those that did not use the system. So, how many students does this reflect here? 290. So, we'll come back to this as we go on. And actually, I have it in this case here. That's good. So, the students that were satisfied with this experience. So, let's think about that for a moment. And we want to look at our list that were satisfied. So what we would do here is draw our line, add them up, and this column is 144. Now, how many students were there altogether? Well, we said altogether there were 290. So to work out letter A here, it's going to be the ratio of 144 to 290. And we'll give you the specifics of this a little later. Again, while this chart is here, we want to just do some brainstorming. All right, letter B. The student was satisfied given that they were a senior. Well, here we have to add horizontally and get the total. And when we do that, we get 43 seniors. This is conditional probability. And how many were satisfied? Well, 22. And then this converts to a percent. All right, in letter 3, the student was dissatisfied given they were a freshman or a sophomore. Now, when we add up these columns, the sum of this and the sum of this, we find there are 161 freshmen and sophomores. So again, this is conditional probability. We're asking for some specifics dissatisfied out of this group. So the dissatisfied there looks like 54. Adding these two groups together out of the total. And that will give you something. And in part D, the student was a graduate student given that they did not use the financial aid office. Well, they were a graduate student. So how many graduate students did we have? Now, for this one, we'd have to add up those students that did not use the service, and that was a total of 67. And in fact, we're looking for graduate students that did not use it. So these were all the students 67. So in a sense, this is our fraction right here. 19 out of the group that we are selecting. Remember, this is conditional probability. Okay, we'll see the book work this out too, but I thought we'd do a little brainstorming, seeing it on this page, the way I've laid this out. So for part A, again, we add up all the students that were satisfied, 144, out of all the students, 290, and then here they give the decimal fraction. It's approximation. So again, you want to have all of this information, but yet see how it was worked. For part B, we're limited to the seniors. So we add up our senior group and get 43. And then those who were satisfied, 22 out of 43. And it gives us this. Now you're going to pause as you do your calculations. You want to have good records. I see lots of potential quiz questions here. Now for letter C, we're looking at conditional probability. So we have to find out what's our total freshman-sophomore student count, which we said was 161. And then we're looking for dissatisfied students, which were 54, adding up those last two. And we get 54 out of 161, which gives you this decimal fraction. Now again, these wavy lines indicate approximation because we're rounding off a little. All right, for letter D, again, conditional probability. What is our sample space here? They were students who did not use the financial aid. We had to add up that last column vertically, and we got 67. But they're specifically asking graduate students that didn't use it. So it would be 19, our last item, over 67. And when we do the fraction, it's 19 over 67, which is this. So in conditional probability, it is so crucial to read the example carefully and follow the conditions they're giving you in the example. And otherwise, it's a ratio and a little bit of arithmetic, but picking out the correct data. Okay, now this is our last example in our flipped classroom video series, and good title, Putting It All Together. Now, this could have been for females, but for some reason they picked men to illustrate this. So it is somewhat tedious, and the slides go through it very, very well. Take some good notes, and let's look at what they have. Studies show that men have a 1 in 6, or about a 17% chance of developing prostate cancer. Now, in the doctor's office, they do have a test, which is called the PSA test. And from my biology days, I recall this is prostate-specific antigen. So an antigen is something they find in the blood. They do a blood test, and they're looking for levels of this antigen. Now, an antigen is a chemical like, we have in our blood types, B antigen, A antigen. O is the lack of either of these two antigens, if you are familiar with blood typing. All right, that's too much information, actually. But let's go on. So the PSA test is used to detect prostate cancer. And what they do is they give you a reading. They'll say your PSA number is 2. And that's good. That would be negative. Or they say it is 7. That is not good. That would be a positive. You have too much of this. And again, we're not going to go into all the specifics of it, but this is what the PSA test does. Now, this test can give either a positive or a negative result, depending on its number in a number scale. Now, an interesting thing is studies also show that of those men who have, in fact, developed prostate cancer, their PSA test is negative, interestingly, 15% of the time. On the other hand, studies have shown that 58.5% of all men receive a positive PSA test. And this is, they're not making this up. This comes from data collected at the Mayo Clinic and can be verified in this link below. So what does this mean? Well, it means that you may have a high result in your PSA test, but you don't have the cancer. So for this case, they would do like a biopsy, perhaps, and they can do other things too. So this isn't, as you probably can see, not a great test, but right now in their toolkit for testing, this is the one that's used a lot. Now, this is background, and what I did in my homework or flipped classroom video lecture log, I wrote some of this information down. So let's get on to the testing. So, question A. What is the probability that a man develops prostate cancer? Well, as you know, if you've taken some notes, this is our first item, that it's stated in the information given, 1 in 6, or about, we said, 17%. So this one was stated in the information. Part B. What is the probability that a man with cancer has a negative PSA test? Now, this was also stated. This was around, see if you remember, 15%. Okay. Now, again, this is all using a number of different things. What is the probability that a man with cancer has a positive PSA test? Well, I'm going to give you some background on this because this relates to a couple of things. And we're going back to our Venn diagram. Now, we had said here that a man with cancer has a 15% chance that his PSA test is going to be negative. So if we set that up in a Venn diagram, 15%, what is the complement then of that? And that would be all of this out here. Remember, having prostate cancer, we're saying, is 100%. Having a PSA test that was negative is 15%. So the complement of this is going to be 85%. And we can think of these as decimals if you like, or if we think of them as percent. So we'll see this worked out, but I wanted to give you a little background. And for letter D, what is the probability that a man has cancer and has a positive PSA test? And I'll show you the math of this here shortly. And then what is the probability that a man with a positive PSA test has cancer? Okay, ready to go on. A little bit of a background. Again, pause is needed. Solution to part A. Again, we were told this in the information given. That would be 1 out of 6 for part A. Generally, 1 in 6 men develop prostate cancer, which is this repeating decimal, about 17%. For part B, again, we were told this, that those who have cancer, prostate cancer, have a negative PSA test 15% of the time, which is 0.15. Now for part C, we want to know the possibility of a positive test given a man that has cancer. So our conditional group is those that have prostate cancer. Well, we said it was 15% of the time that they don't have a positive PSA test. That is, they would have a negative PSA test. And here they're actually saying they're going to use the complement to find this. So 1 is the all men, 100% of men with cancer. We're going to subtract from that 100%. Remember, 1 is 100 over 100. Subtract the 15 from it, and it gives us the 85 over 100. Again, we showed this using the Venn diagram, and there's where we get the 85. 85 is, in a sense, the complement. If 15% don't have a positive test, then 85 has a positive PSA test. Now, for letter D, again, we'd have to go back to your notes, use the multiplication rule for dependent events to find the probability of having cancer and a positive PSA test. And this would be the layout of our value. And it would be positive given they have cancer. So we know from our earlier data that 1 in 6 men will have prostate cancer, and that have positive results would be 85 out of 100, which gives this fraction, just multiplying through, since you're using your calculator, and it gives you this decimal. So just under 15%. Now, for this last one, this is, I think, one of the most challenging we've had in the whole course. It says, be careful how you read this question. It's slightly different than the previous one we just answered. We want to know the probability of a man actually having cancer, given that he's had positive results. Since we weren't given this information, we'll need to rearrange the multiplication rule for dependent events to help us. And this was the basic formula. The probability of A given the, or multiplied by the probability of B given A. So they're using a little algebra and eventually end up with this. So take a moment to write it out. And we know for positive cancer we had this result. And positive PSA test we had this result. So we're going to take this and divide it by this. You'll see it in the next slide. There it is. And then we convert it to multiplication of fractions. And again, using your calculator. And pause it as needed. You get this. Reducing it to this. You don't have to reduce it. We'll just knock off these zeros here. And you get this. And what is this about? Well, it's about 1 out of 4 that has a positive test, PSA test, would actually have cancer. So as you can see, they're looking for a better test, but this is what they have so far. And this is sort of summarized as what is called Bayes' theorem, which is what we just had. Now here, your value of P has to be greater than 0. Okay, again, I don't expect you're going to have one like this on your test. You might have one like this to play around on your homework. But again, bring homework questions into class. We're happy to help, and they are challenging. And as we get ready, we'll be preparing for our test on our last unit and then the final exam. So this winds it up.